Okay, this is your second video on transformations. Specifically, we're looking at reflections now. I think you're going to find this one to be one of the easier transformations that we're going to look at. There are some ways that you can get confused, so and I'll highlight what those are, but you're going to find this one to be one of the easiest. Reflections are just like what they sound like. When you're brushing your teeth every morning, hopefully, you look at your reflection every day, and it's similar to that in the sense that you're not looking at yourself, you're looking at a reflection of yourself. If you have words on your shirt, those words are going to appear backwards. So when you reflect, you are reflecting and you're going to be seeing the mirror image of a reflection. We're going to be in the coordinate plane doing this, okay? One thing that you need to remember when doing transformations, and I didn't mention this in the last video, but this applies to all of your transformations, you are going to transform the points first, and then you connect the dots to get the shape. You don't try to do one point and then connect the dots. You're going to get all kinds of confused. You're going to do all of the points first and then connect the dots, and it's going to be a congruent image for the first three transformations, and then for dilations it's going to be similar. Okay, we'll talk about what that means. But if your shape looks if you do a transformation of a triangle and you get a square, that's a problem, okay? So you're going to do the points first, and then you connect the dots, okay? A reflection is a flip. And when we think of a reflection, that there's an FL in that word reflection, it's a flip. We all have seen a reflection before. We are going to be in the coordinate plane doing this, and we're going to flip. You have to flip across a line, and you're not going to be flipping across a point. You're going to be flipping across a line. We call this line your line of reflection or a line of symmetry, okay? So if I had to draw a line of symmetry in that picture there, it would be something like right there, okay? Because it's going to be the same on both sides of that line. It's just the point you're reflecting, or the line that you're reflecting across, okay? One property that you need to be made aware of is that the distance from the image to the line of reflection, so your answer, the distance from it to the line of reflection is going to be the same distance as your original figure to the line of reflection. So remember, you're going to do the individual points first, and then you're going to connect the dots. So if you can do points, you can do shapes. That's all a shape is a series of points, okay? Here is our first question. It says reflect the triangle, and we have the point ABC, so it's triangle ABC, and it has points at 4, -2, 3, -5, and 1, -4. And we're going to reflect this across the x-axis. Again, what is your answer going to look like? The question is, what are the coordinates of A prime, B prime, C prime? Your answer is going to be ordered pairs, okay? You're going to have 3 ordered pairs. You're going to title them A prime, B prime, and C prime. And there are 2 ways we're going to go about doing this. In the last video for translations, we did the algebraic way first, and then we did it drawing a picture. I want to show you what the picture would look like first here, and then I want to show you the algebraic way of doing it. See if we can find a pattern here, okay? So you have this graph right here, and I'm going to kind of, well, we're good there. All right, so we are going to reflect this across the x-axis. We're going to do the points first. So the distance from A to our x-axis, you are 2 units away. So you are going to be 2 units away on the x. You're not going to go left or right at all. It's going to be just flipped across the x-axis right there. So this is what we're going to call A prime. And we don't start drawing our triangle right now. You're going to do the 3 points first and then connect the dots to make your triangle. Okay, if I started drawing this triangle, I'm going to get all kinds of confused about where to put my next point and all, where it stops and where it starts, and I don't know what I'm doing after a while. Do point B next. You are 1, 2, 3, 4, 5 units away across the x. You're going to be 1, 2, 3, 4, 5 units away across your x over here. We're going to call this B prime. And then C is at 1, 2, 3, 4. You're 4 units away. It's going to be 1, 2, 3, 4. It's just that easy, okay? This is going to be a reflection across the x-axis. And as you can see, it is congruent. Means it's the same size. It's the same shape. What is different between a reflection and a translation is the reflection is going to look backwards. It's going to look flipped. Translation is the exact same thing. It's just going to be at a different spot on your piece of paper. It's just been slid from one spot to another. So this has just been flipped. A prime, B prime, and C prime. So let's see if we can find a pattern here. Our A was at, what is that? 1, 2, 3, 4, 5, negative 2. Our B was at 1, 2, 3, 1, 2, 3, negative 5. And our C was at 1, 1, 2, 3, 4, 1, negative 4. When we reflected, we got A prime. And if we look over here, the coordinates of A prime are going to be 5, 2. When we reflected B, we got B prime, and it became 3, 5. So I'm starting to see a pattern here. C prime is going to be at 1, 4. So we went from 5, negative 2 to 5, 2. 3, negative 5 to 3, positive 5, and then 1, negative 4 to 1, 4. If you see the pattern here, you wouldn't say that the general rule is you make all the second numbers positive. That's not the rule, because if it's negative, it becomes positive, but if it was positive, it would become negative. So you're going to change the sign. Instead of saying that, excuse me, instead of saying make it positive or negative, you say when you're reflecting across the x-axis, all you do is you change the sign of the y. Okay? Your y value. Remember, in every ordered pair, you have an x value and a y value. So I don't even need to draw a picture if I can remember this rule. Okay? So I'm just going to put this right here. When you reflect across the x-axis, you change the sign of the y, or change the sign of the y value. Okay, so if you change the sign of the y when you're reflecting across the x-axis, the opposite is going to hold true when you reflect across the y-axis. When you use the y-axis as your line of symmetry, you're going to change the sign of the x. Okay, so if you know those rules, you don't even need a picture anymore. Now, I've never seen a question, I've never given a question in which there's not a picture given to you. Okay, more often than not, a picture is going to be given to you, but you just need to, if you understand that rule, you'll never get the answer wrong. And remember, our answer to this question is not the picture. Your answer was those ordered pairs that we wrote down in the last part, the A prime, B prime, C prime. It was 4, 2, 3, 5, 1, 4. That was your answer. It's not the picture. It's to answer the question. Your answer is going to be the coordinates of the prime image. Okay? So, yeah, okay. Well, that's where we're supposed to write our rule for y. So I guess I could put that down there. All right, so let me tell you the most common error. Boop. Change the sign of the x. Most common error that kids make is they reflect across the wrong axis. If you reflect across the wrong axis, it's like the one mistake you're going to make, and it's the one mistake I'm telling you not to do. If you reflect across the x, make sure you are reflecting across the x-axis. You're going to see this written on your paper, on your test, and I'm going to draw like some eyes, like crying. Well, I don't even know how to draw that. You get the picture, though. Like, if you reflect across the wrong axis, that's the one thing you're going to do wrong. All right. The other way these questions could look is I would give you the picture, and it would say, name the transformation that has occurred, and you would just look at this picture and you'd say, it has been flipped. So I know that's a reflection, okay? Stay tuned. Next part is going to be on rotations.